We're going to use a technique of integration called method of partial fraction to evaluate the integral of x plus 5 divided by x squared plus x minus 2. In order to use method of partial fraction, we have to make sure that we're integrating a rational function that is a polynomial let's call it polynomial 1 divided by polynomial in the denominator. Let's call it polynomial 2. And of course, in this case, that's what we have. Now also, we have to make sure that degree of polynomial 1 is strictly less than the degree of polynomial 2, because if it's not, we have to perform long division and then to get it in the form where we can use method of partial fraction. Well, in this case, degree of polynomial 1 is 1, degree of polynomial 2 is 2, so we're okay here, and then we can proceed. Now take polynomial in the denominator, x squared plus x minus 2, and see if it can be factored. It can be factored. It is x plus 2 times x minus 1. These are both linear terms because the degree is 1 and they are distinct. So it's distinct linear terms. And there are two of them. Next step is to perform partial fraction decomposition. We take x plus 5 divided by x squared plus x minus 2, express the denominator as a product of those two linear terms. So this is x plus 5 over x plus 2 times x minus 1. And now write this as decomposition. Something over x plus 2 plus something over x minus 1. Because these are linear terms and they're distinct, we just put a different constant into the numerator. So we have to find a and we have to find b. And we have to do that, just do a little bit of algebra. We take x plus 5 over x plus 2 times x minus 1 and multiply it by x plus 2 times x minus 1. So these cancel, and we do the same thing on the right. A over x plus 2 times x plus 2 times x minus 1 plus b over x minus 1 times x plus 2 x minus 1, and we end up with this. X plus 5 is equal to a times x minus 1 plus b times x plus 2. Now we can match terms. Polynomials are unique, and then we can find a and b, or we can carefully select constants for which this is true for anything. So let's pick constants that make one of the two things on the right 0. Those constants are x equals to 1 and x equals minus 2. Plugging in 1 for x on the left, we get 6. Plugging it in on the right, 1 minus 1 is 0, so the a part is gone, but 1 plus 2 is 3 times b. That's 3b, and b has to be 6 over 3, or 2. Now plugging in minus 2 plus 5 is 3. The b part is gone, and for the a part, minus 2 minus 1 is negative 3 times a, so a is equal to minus 1. We're done with decomposition, and our term x plus 5 over x squared plus x minus 2, it's the same as x plus 5 over x plus 2 times x minus 1, is now a, which is minus 1, divided by x plus 2, plus b, which is 2, divided by x minus 1. Now let's return to our integral. The integral we wanted to evaluate was the integral of x plus 5 divided by x squared plus x minus 2. It now can be expressed as the sum of two integrals minus integral of 1 over x plus 2 plus 2 times the integral of 1 over x minus 1. The integrals on the right are very easy. They're just natural logs. There's no need for any substitution. So this is minus ln of absolute value of x plus 2 plus 2 times ln of absolute value of x minus 1 plus c. We can leave the answer in this form or simplify it. This is minus ln of absolute value of x plus 2 plus ln of x minus 1 squared. We can take this 2 and put it in the exponent, and since anything squared is going to be positive, we're not allowed 0 into ln. We don't need absolute value, it will be redundant, plus c, and then we can combine these two. This is natural log of x minus 1 squared divided by the absolute value of x plus 2 plus c. That's the final answer. For more videos, visit www